Now that we've taken a look at some of the key operators in the Flux class, it's time to put them all together in the context of our first case study. This case study will illustrate the operators we've talked about thus far and show them in the context of being able to multiply and reduce various big fractions. The case study explores the use of the just, from iterable, from array, from, do on next, map, merge with, repeat, and subscribe operators. You can take a look at the case study source code here at the link at the bottom of the slide, and I'll now go ahead and walk through that case study in my IntelliJ project. We're now in my IntelliJ project for the ex1 case study. Let's first take a look at the ex1 class itself. This is what we use as the main entry point. And as you can see, is always the case, we go ahead and use our async task barrier to register several test methods that will be run. In this particular case, all the methods are going to run synchronously because we haven't really talked yet about using subscribe on and asynchronous Flux processing. But we still use the async task barrier just to keep the flavor of the different case studies having the same driver program. We're going to go ahead and register the test fraction multiplication sync 1 method, the test fraction multiplication sync 2 method, and the test fraction multiplication sync 3 method. As is always the case, after they're registered, we go ahead and run all the tasks using the async task barriers run tasks method, and then we go ahead and block waiting for all the computations to complete. As you'll see, all these computations are in fact synchronous, but this generalizes to async processing as well. So now let's go ahead and take a look at the Flux EX class. You can see here the first method we have is called test fraction multiplication sync 1, which tests big fraction multiplication using a synchronous Flux stream. We start off by using the just method to generate a stream of big fractions. They're all going to have a numerator of 100 and then denominators from 1 to 4. We then use the do on next action operator to log the contents of the computation by appending it to, in this case, our string builder, indicating what thread this was run in and converting each big fraction to a mixed string, and then putting in what we're going to be multiplying it by. The next operator that we talk about here is the map operator. As you can see, we take each big fraction that was emitted by just, and we go ahead and multiply this by the S big reduced fraction constant. So that'll end up multiplying each of those big fractions by a constant. And then the final method that we are going to show here is the subscribe method. And what we're going to do is we're going to go ahead and subscribe, which triggers all this other processing. It triggers the call to just and do on next and map for each of the elements that we emit from just. And if all goes well, the next event is handled. And in this case, the next event simply goes ahead and will append the multiplied result by taking the multiplied big fraction that we get and turning it into a mixed string. So if all goes well, that'll happen that way. If for some reason an error occurs, then we go ahead and we're going to append whatever error occurred, the error message that occurred in the exception, and then we'll trigger the display of the results. And if all completes successfully, then on the final completion event, we're going to go ahead and trigger the display, printing out the string builder as a string. So you'll see when we run the program, that's what will be the result. The very last thing we do here is we just return something called S void M, which, as you're going to see here, if we take a look at this, is just a final mono that is empty. And that's just an indication to the async task barrier that this is done. Let's now go ahead and take a look at test fraction multiplication sync. This particular illustration is going to create a list of big fractions. So we have a big fraction list using the big fraction value of factor method and the list of factor method that comes out of list. We then go ahead and use the from iterable method. So we're going to take our big fraction list, convert it into a flux that'll emit each of the elements in that list. As before, we're going to use do on next as the action operator to log the contents of each of the emitted big fractions. We then go ahead and use the map transforming operator to go ahead and multiply each of those big fractions that were emitted from iterable by S reduced big fraction. I probably should have shown you what that was before. S big reduced fraction is just a big fraction that has a big numerator and a big denominator, just for fun, just to do something interesting. And then as we saw before, subscribe is called. This is the terminal operator. Just as we saw before, it causes all the other operators to start to run. And then just as before, on the next successful event, it will go ahead and append the result at the end of the string buffer. If something goes wrong, it'll append the error and then display the results. And if all finishes successfully, it'll go ahead and cause the results to be displayed. And it also returns S void M. We finally have a third example. This is test fraction multiplication sync 3, also a synchronous call, not an asynchronous call, but asynchronous call. And in this case, we're going to generate a new random number generator. We're going to go ahead and create a big fraction array this time. Remember before, first time we used the Flux just method, then we used from iterable, and now we're going to create an array, and we're going to use the from array method. And this particular example is going to be kind of fun. Take a look at what we do. We're first going to go ahead and create a flux of big fractions that will take the big fraction array and use the from array factor method to create ourselves a flux of big fractions. Then the next thing we're going to do is we're going to go ahead and use the from call on a flux. Remember, this is the lazy call. From array, from iterable, and just are all eager calls. So they all get handled in the assembly thread, and that's where things get called. From is lazy. And so what we're going to do here is we're going to pass in a lambda expression for creating a random big fraction using the make big fraction method. The make big fraction method, we've looked at this before. It just makes a very large big fraction that in this case is reduced. And we go ahead and use from callable. So that's evaluated lazily. So each time it's called, it'll give you back a different random number. And then we take the flux that's returned from and we repeat it 4 times. So we're going to end up with 4 random big fractions. And then what we do is we take F1, which is the flux that we got from array, and we take F2, which is the flux that came back from calling from and repeat, and then we merge those 2 things together. And so that will create a single flux sequence without any transformations being done. We just want to kind of merge them together, if you will. Then what we do is we take that sequence, we use the do on next action operator to log the result. We use the map operator to multiply each of those big fractions, including the ones that were generated randomly by S big reduced fraction. And then finally, we go ahead and use subscribe, just like we did before. So this example is kind of fun. This third test fraction multiplication sync 3 method is kind of fun because it demonstrates things like using the from method to do things lazily in conjunction with repeat. We also saw how we could use from array to take an array and turn it into a flux stream. And then you saw how we were able to take the merge with operator and merge the results of flux F1 with flux F2. And then we're going to go ahead and print the results out after we do the map transformation. So let's go ahead and run this program. You can see what it does. It's going to go ahead and compile. And here's the results for test fraction multiplication sync 1. You can see these are just the values that are generated using those 4 big fractions we used with the just operator. Then down here, you can see we have test fraction multiplication sync 2. And again, in that particular case, we used the from iterable method, doing more or less the same kind of thing. And then finally, test fraction multiplication sync 3. And in this case, you can see we had double the number of results output because we took the results from big array, of which there were 4, sorry, not big array, from array, to create 4 big fractions. And then we also used the repeat method with the from operator. And then we generated these much larger big fractions. You can see the first 4 are the ones we did up here. But then the next 4 are much larger because they were generated randomly. So they're really big. And then we went ahead and did all the other mapping and reducing and subscribing and printing and so on to get all the results that you see here. So you have a total of 8 results from that. So that's the end of the first case study that we're looking at when we talk about Flux. You'll see that there's lots of other operators we'll talk about later. And in the next parts of the lessons, we're going to be describing the use of things like subscribe on in order to be able to get all this computation to run asynchronously instead of synchronously as we did in this particular case study.